Hello, my name is Kiara Cuevas, and today I'm going to be going over the atomic structure, the number of protons, number of neutrons, electrons, cations, anions, electromagnetic spectrum, and electron configuration. The atomic structure of an atom is just three particles: electrons, which is a negative charge. It is usually the same number of protons, which is atomic number, if the atom is neutral, which means it has no charge. Protons, on the other hand, have a positive charge. They are equal to the atomic number and have an impact on the atomic mass because of the neutrons here, which have no charge. And to find the number of neutrons if not given, you just have to subtract the atomic mass and the protons, which means it impacts the atomic mass. So if you add protons and neutrons, you will get atomic mass. Like I said, a neutral atom has no charge and it has an equal positive and negative charge, which just means that protons and electrons are equal. So if you just sum it up, electrons and protons will be equal if it's neutral. If not, you can just subtract them and you will find the charge. Up next, we're going to talk about the chemical symbol exactly. So we're going to start off with X, meaning just the atom. The A on the top subscript is going to be the mass. The bottom Z is going to be the atomic number. And the top right is going to be the charge. So like I said, the atomic number Z is going to equal the protons and the electrons if it's neutral, so meaning no charge at all. The mass number A will equal protons plus neutrons, getting the mass. So A minus Z is going to equal neutrons, which is mass minus protons. We're going to start with an example of neon, which has 10 as an atomic number, 20 mass, and no charge. We're going to put up together a little table. Is that the symbol is Ne, neon. The atomic number is 10. The mass is 20. Number of protons is going to be 10, which is equal to the atomic number. Now, like I'm showing here, the neutrons is going to equal 10, which is next, what I found were the electrons, which is just the protons minus the charge, was just going to be the same thing, so 10. So at the end, the neutral is going to have the same amount of protons and electrons. So like I said, an atom would only have a different amount of electrons if it is electrically charged, so that means the protons and electrons will not be equal. That will be named an ion. Like I said before, to find the atomic charge, you can just subtract the number of protons and the number of electrons. That is meaning that it's either gaining or losing a charge. Electrons. If the charge exhibits a negative charge, it is an anion, and if it exhibits a positive charge, it is a cation. Now we're going to review some examples of those. First, we're going to start off with an anion, and we're going to stay with the neon atom just to stay clear, with the 10 as atomic number and 20 as atomic mass, and the charge is just going to change. You know that the symbol and everything, protons is going to stay the same, mass is going to stay the same, neutrons going to stay the same. Since the charge is negative, it is an anion. The electrons is just going to be the protons minus the charge, which is going to equal 12. Next is going to be a cation, so the charge is going to be a positive 3. So to find the electrons, you're just going to subtract the protons and the charge, and you're going to find the new electron. The number of protons and neutrons stay the same unless the mass is given otherwise. So that's just going to be named differently. And now we're going to look into some isotopes, which I'm just trying to explain here. The electrons just depend on if it's electrically charged or not. An isotope is an atom of the same element that contains the same number of protons but different number of neutrons. Now look at some examples of those. Still using neon, just changing the number of mass. We're just going to stick with the same number of protons just to find neutrons. Like I said, you can subtract the mass and the protons. And here we go. 22 minus 10 is going to be 12. Doing one with a mass of 21, one with the mass of 24. Next, we're going to talk about is electromagnetic radiation, which just means that it showed the light was visible part of a vast spectrum of it all. A visible light and other forms of electromagnetic radiation are just used to infer the energies of electrons within an atom or molecule. Some examples of these are just the energy used to cook the food in your microwave, the heat of a hot object, which is just a red object, X-rays, TV screen. the radiation coming off the TV, the radio waves from your phone while you talk on the phone or as you're texting. Going off of that, we're going to go into the electronic spectrum, which just shows the range of energies that the radiations can compromise. This is going to go into wavelength, frequency, how energy goes affecting that, the different types of wavelength, and how the waves go. Decided to make this explanation easier by just adding a picture of the electronic spectrum. It is showing the different types of radiation, how the wavelength increases, how energy increases, and how frequency increases. Going in by starting off with a couple examples.